Okay, welcome to this. Welcome to this next video, 1.3. We're going to be looking at operations on fractions for this one. Again, this is some stuff that you've probably seen a lot of already from grade 7, but we're sort of just covering it, smashing through it, and you can just, as we sort of discussed before, go through it as fast as you want. Okay, so our learning goals change a little bit. So we've got here that students describe rational and irrational numbers. So we'll talk about what they mean in a moment. Now, at the end of this, you'll be able to understand the difference between rational and irrational numbers and to correctly perform simple operations on fractions. Okay? Right. So let's talk about different sets of numbers. Like we just spoke before about rational and irrational. So what do those kinds of things mean? Well, we've already talked about so far one particular set of numbers, which was that Z number set. Okay? And this, capital Z, that's our integers. Okay, remember that was all the negative whole numbers, positive whole numbers, and 0. Okay, they're our integers. We also have a set of numbers called the natural numbers. Okay, and that's usually 0 and upwards. Okay, everything 0, 1, 2, 3, all your whole numbers from 0 upwards. Sometimes they're called counting numbers. Okay, but they're your natural numbers. Right, we also have the set Q, which stands for our rational numbers. Okay, now they are numbers that can be expressed as some number over another number, where A and B are elements of the integers. Okay, so it's basically rational number is a number that you can express as a fraction of integers. Okay, so numbers like a half, or 6, or 296 over 13. They're all rational numbers because you can express them as fractions. Okay, right, we have the irrational numbers. Obviously there's no letter for that, but the irrational numbers are numbers like pi and phi and e and what else? Square root of 2. Okay, they're numbers that can't be expressed as a fraction at all. They're just sort of a series of numbers. Okay, right. We also have I, which we'll talk about some stage later probably. These are the imaginary numbers. Imaginary numbers, which it's a bit hard to explain. They're sort of numbers that have there's an imaginary number I, which is equal to the square root of -1. And we might talk about that in class about why that doesn't work from our point of view. Okay, and lastly, well, second last, we have C, which is the complex numbers, which are numbers that have A plus BI, so we have a real part of the number and an imaginary part of the number. Now all this stuff might seem crazy to you, but I'm just sort of going through it to tell you that maybe this rational stuff does actually have a place in number theory. Okay, we've also, if we've got imaginary numbers, well, we also have real numbers, which are all these integers, natural numbers, rational numbers, irrational numbers, all sorts of stuff. They are all the real set of numbers. Okay, but yeah, we'll cover that in class a little bit more. All right, let's quickly fly through this stuff. So equivalent fractions, remember, they have the same value. So we can say that half is equivalent to 3 over 6. Okay, because they have exactly the same value. And remember, to go between equivalent fractions, we multiply the numerator and the denominator by the same amount. So 1 times 3 is 3, 2 times 3 is 6. Okay? So there are our equivalent fractions and how we make them. Alright? Now, let's sort of scroll down again. Now, addition and subtraction of fractions. Now, here's the important thing when we're adding and subtracting fractions is that, notice these denominators are different. Okay? There's 3 and a 6. Okay? So, if there's different denominators, different denominators, you create equivalent fractions. Wow, good writing today. Equivalent fractions. So denominators are the same. Okay, now, and ideally that number is going to be the lowest common multiple of the two. Okay, now this is a pretty easy one, you might sort of recognize. Sort of a reason for that, really, we're just sort of flying through it. So we have 2 over 3 plus 1 over 6. Now this is the way I want you to set it out, as we're doing it in class as well. Now we have 3 and 6. Now you could just do all sort of cross multiplying stuff, which sort of works, but it's easier to sort of rationalize and think your way through it. Now to get 3 to become 6, remember, this is an easy one. I can go 3 times 2 to make it 6, right? But if I'm going to do that to the bottom, I also have to do it to the top. That's really, really important. Okay? So now I rewrite it. So I now have 4 over 6 plus 1 over 6, and that's going to be 5 over 6. Because remember, when the denominators are the same, like this, you just add the numerators together to get 5. Okay? Right. Same kinds of things happen when we are working with our subtraction. Now I'm going to show you that you can do the cross multiplying thing as I've seen before, because it will always work. You just might not always finish with the simplest fraction. You have to work with it. Okay, so cross multiplying means sort of all this sort of junk here, but I want to show you a better way. I'd like you to set that up. If the denominator of this side is 6, I'm going to times this by 6 and this by 6, and this side is going to get times by 5 and times by 5. Okay, because 5 from this denominator. Right, let's rewrite it. I'll have 24 over 30 minus 5 over 30. 24 minus 5 is 19 over 30, and we're done. Okay, now with this one, we're always going to say to ourselves, do we have our simplest fraction? Well, with your simplest fraction, to find that, you divide them both by their highest common factor. But 19 and 30, the highest common factor is 1. How do I know? Well, straight away, 19 is a prime number. So those are the kinds of things you want to try and keep buried in your mind so you can quickly bring them out. Okay? Right. Let's move on quickly. We have multiplication of fractions. So multiplying fractions is super easy. Okay? The idea here is you just smash them together. Okay, so if I have, like that, 3 over 4 times 8 over 9, what we do is we multiply these two together and multiply these two together. Alright, so we'll get 3 times 8 over 4 times 9. 3 eighths is 24. 4 nines, 36. Now, they have a highest common factor of 6 because it goes into both of them. Actually, they have a highest common factor of 12, but I'm going to show you that we can divide by 6 first. Divide by 6, and we're going to get 4 over 6. Now we can divide them both by 2 and get equaling 2 over 3. Done. Okay, so that's how we do our multiplication of fractions, just sort of smash them together. Alright, division of fractions. Quickly, for these ones here, we instead, rather than divide, we multiply by the reciprocal, okay, which means that we flip the second one and multiply. Okay, so rather than 4/5 divided by 3 over 4, we change it to being instead 4/5, so that one stays, multiplied by 4 over 3. So see how that last one flipped over when we change it to multiply, and so that we did the same thing as we did before. 4 times 4 over 5 times 3 is 16 over 15. Okay, and they don't have any common factors, so we're just going to leave that there. Okay, directed fractions. So these essentially behave the same as directed integers. Okay, so the same rules that apply when we're multiplying, subtracting, adding, and dividing with negatives with integers apply for fractions as well. Okay, sorry this was quite a long video, but I was just trying to get through a whole lot of stuff you've probably seen before in grade 7, and really encourage you to get going and smashing through the exercises. Okay.